This unit is on developmental psychology. Developmental psychology has to do with those changes in the way that we think and in our emotions and in our social interactions over the course of the lifespan. Developmental psychology is fascinating to many students, and so while we only will have the chance to dip very shallow into this topic in this course, you may want to think about taking a course in developmental psychology if you're interested in this topic. Let's go on to the next slide and begin looking at some of the psychological tasks that happen during our development. Consider what major events happen during these life periods. This question illustrates some of the psychological tasks that happen throughout life. So for example, in the first year of life, what is a major event that happens? Typically the things that happen in the first year of life are very much physical tasks, like learning to roll over and sit up, hold the head up, maybe even stand. But they're psychological tasks as well, such as learning to say the first word. As we move into the second year of life, some of the major events involve the child developing his or her own sense of will and maybe having conflict with parents over what is appropriate or what should be done. Or, for example, the terrible twos when a child and a parent butt heads over what needs to be done. In the preschool years, we see children developing more of a social world and initiating stories, initiating tasks. As we go on to the grade school years, the emphasis psychologically becomes achievement, and children are focused on doing well as they can in the various areas of their life, including schoolwork. Within adolescence, we have another psychological focus, where the child is beginning to wonder who he or she really is and beginning to shape and define who he or she is in relation to the world, that is, to develop a sense of identity. Moving into young adulthood, some of the psychological tasks are finding a mate for life, having children, establishing a home and a career. Moving into middle adulthood, the psychological landscape changes again, and people in middle adulthood tend to have the psychological task of trying to figure out whether the first half of their life was worthwhile and what they're going to do to make a difference in the second part of their life. And in late adulthood, psychological tasks again change and may involve trying to figure out whether a person's life was worthwhile and come to grips with impending death. Let's go on to the next slide and we'll look some at the definition of developmental psychology. Next slide. So what is development? Development is defined by psychologists as a change in our capabilities that occur across the lifespan. Now these capabilities are going to be physical, cognitive, or that is the ability to think, and also social capabilities. As we look at human development, there are several characteristics that stand out, and these are made clear, I think, by the previous slide. The first is that development involves specific milestones. Milestones, whether they're physical, cognitive, or social, are specific events that happen. They're markers of development. So early milestones in development are things like the child being able to hold their head up, or to push up on their arms, or to crawl, or to take their first step, or say their first word. These are specific milestones. But we see those milestones occur even as we get further on in life, such as marriage, graduations. Those are milestones that may be in your future. The second characteristic of human development is that it occurs in pretty much a predictable sequence. That is, in most people we're going to find this milestones occurring in the same sequence. The reason for this is maturation. Maturation refers to the biological ability to reach these milestones. So for example, during adolescence, people tend to be able to solve more difficult math problems. They might be called abstract problems. And an example of this are algebra problems, in which we can use letters such as X or Y to represent possible numbers. Now, prior to adolescence, the brain structure of children, the brain development of children, is incapable of understanding some of these abstract concepts that can be learned in adolescence. So milestones have to do very much with the maturation of the brain and the body. But we can say that there's pretty much a predictable sequence throughout life. We know that children need to learn to stand before they can walk, and they need to learn to walk before they can run. The third characteristic of human development is that timing of milestones really can vary from person to person. So while in almost everybody we'll see the same sequence of milestones, the timing may vary quite a bit. That is, for example, one child might say his or her first word at 9 months of age. Another child may not say a word until 15 months of age. Some children walk before 1 year. Some children walk significantly later than that. So the timing may vary from person to person, even if the milestones do occur in a predictable sequence. Next slide. Psychological development really starts during the prenatal period, and so it's possible to think in terms of psychology as something that spans not just from birth, but all the way from conception through death. So let's look at some of the psychological developmental things that happen during prenatal development, because it's such an intensely active period of psychological and physical development. To begin with, at conception, our genes determine our sex, our hair, eye color. But beyond that, there are psychological characteristics such as personality and intelligence that are in part determined at conception as well. Personality and intelligence, as you'll recall from behavioral genetics, are things that are not entirely set by our genes, but are definitely influenced strongly by our genes. So we might say that even from conception there are psychological functions such as personality and intelligence. At 24 hours after conception we begin to see the first cell division, and 8 days after conception cells begin to differentiate. That is, they tend to become different types of cells. So we may find nerve cells, and we may find cells that are going to become skin cells, and cells that are going to become connective tissue or bone cells. At 10 days, there is an implantation into the mother's uterus. That connection is made with the mother, which will nourish the baby throughout the entire period of throughout the entire prenatal period. At 2 weeks, the term that's used is called an embryo. So from 2 weeks on up to the 9th week, the developing embryo has a variety of psychological things that are going on. At the beginning of the 3rd week, we see that the first nerve cells, true nerve cells, neurons, have formed. Skin is evident only 3 weeks after the conception. And we see the beginning of the backbone, which is obviously going to house the spinal cord, an important part of the nervous system. During that 3rd week, about the time that a woman is aware of having missed her period, the heart starts beating and the liver is evident. So we're getting things set up for life here. Next slide. Continuing on, in the 4th week we see the head evident and the beginning of the eye. And we've talked some already about the importance of vision to our psychological functioning. In the 5th week we see clearly that there is an eye, nose, and a mouth evident. So these modes of sensing and modes of communication, human communication, are being founded at this time. In the 6th week, the embryo is already in constant motion. Arms, legs, hands, even fingers are moving. What is causing this movement? Clearly there must be neuron action happening to innervate these muscles and cause movement to occur by the 6th week after conception. 7th week after conception, neurons are connecting with each other. The early nerve paths are already starting to form and in place. By the 8th week, we find that every single organ is formed and in place and has merely to continue to be developed and perfected. At the 9th week, as I mentioned before, embryo is no longer the term, but the term that's used by doctors is fetus. And at the 9th week, it's clearly a human appearance of this developing baby. By the 6th month, babies are capable of surviving outside the womb. Of course, that's with help, and not every baby can survive that early if they're born prematurely, but there is that capability. So you can see there's a lot of foundation that's happening during the first 9 months of life during the prenatal period. Let's go on to talk about some of the things that happen then once the child is born. Next slide. Are there psychological things that newborns can do? Research is finding an amazing variety of things that babies can do. And these are things that involve the nervous system and psychological sorts of functioning. So to begin with, some of the things that we find early on are reflexes. So for example, the crying reflex. Now when you think of reflex, you may think about the doctor tapping you on the knee and your leg kind of kicks a little bit. That knee-jerk reflex is an extremely simple reflex in comparison to some of the reflexes that we have built into us when we're born. For example, the crying reflex involves the respiratory system and the voice. It involves tearing up. It involves changing to blood flow to the face. Many different body systems are involved with that reflex of crying. The startle reflex is a reflex in which the child, if the child is dropped or if the child is even loses support, you're holding the child and you lower it quickly, its arms will shoot out and it will grasp for something to hold on to. Rooting is a reflex in which the child seeks out a nipple if there's any contact with its cheek, like a blanket or a hand or anything like that. The child will orient towards that and then begin the sucking reflex and the swallowing reflex. There's also a reflex called a stepping reflex that occurs fairly early on and then tends to disappear. But in newborns, the stepping reflex is a reflex in which if you hold the child upright and drag the newborn's toes along a surface like a table, it will actually reach its legs out and it will take steps. It can't, of course, support its weight at that point, but it still attempts to take steps reflexively. Other psychological things newborns can do don't involve so much reflexes as what we might call adaptive preferences. That is, what does a baby prefer? So some of the things that babies prefer, research has shown, are human voices. To listen to the choice of a human voice or the voice or sort of a mechanically generated words. If you put those sounds on either side of a newborn, the newborn will orient or turn towards the human voice rather than the mechanical voice. If you give the baby a chance to recognize its mother's voice, it will show indications of its mother's voice, of recognizing its mother's voice. So for example, a baby will suck harder at a bottle or a pacifier when it hears its mother's voice than it does when it hears another voice. Babies also prefer the smell of their mother's body early on. So the mother's clothes or the breast pad of a nursing mother is placed on one side of the baby and the breast pad of a different mother placed on the other side. The baby will orient to the smell of its own mother's body. Babies also have preferences for eye-like patterns and face-like images. If we go on to the next slide, you'll see an example of face-like images. Next slide. So if you were a newborn, which of these figures would you prefer to look at? I've never had any student say that they think they prefer to look at the figure on the right. It's so clear that the figure on the left, even though it's extremely simplistic, it's so clear that it's face-like, and it's much more attractive to newborns than the figure on the right. So just another example of those adaptive preferences. Next slide. Here's some examples to illustrate cognitive development. These are quotes from my own kids. At age 2, one of my kids liked to play a game in which they would cover their head over with a cloth and call out, "Where am I?" And then they would pull the cloth off and say, "Here I am." However, they didn't have the language ability to phrase it like that, and so my child would say, "Where is me?" and pull off the cloth and say, "There me is." This is a very simple repetition on the part of my child of a game that parents often play with kids. Where is Johnny, or where is Susie? There she is, or there he is. Now another example of a quote from one of my kids at age 4. One of my kids said, "You know, instead of getting a cold, I'm getting a warm." Somebody in the family was catching a cold, and the child said, "Instead of getting a cold, I'm getting a warm." This is a little more complex thinking about not only that there's opposites such as cold and warm, but that the word cold could mean an illness, or it could mean a state of temperature, feeling cool or warm or whatever. So more complex cognitive functioning there. Look at this quote at age 8 from my daughter. She had a friend named Helen and asked, "Okay, was my friend Helen born knowing Chinese, or did she learn Chinese?" This is more complex cognitive functioning yet, thinking about something like language and maybe where language came from. So across the lifespan, we see changes in cognitive development, but particularly in childhood. Now recall, we've talked about cognition already. Cognition really refers to mental activity. So activity like thinking, knowing, remembering, believing, even communicating are all considered cognitive activities. Let's go on and look at a theory of how cognitive activity develops over time in human beings. Next slide. The forerunner in understanding cognitive development was a Swiss psychologist by the name of Jean Piaget. Piaget worked for Alfred Binet, who developed the first intelligence tests. We've talked about him previously. And Piaget was a helper, and he did testing of children. But what fascinated Piaget was not so much the intellectual ability of children, but rather the mistakes that they made when they were taking items from an intelligence test. Piaget became convinced that children don't have less intelligence than adults, that they have a different kind of intelligence or a different kind of cognitive ability than adults. So in a sense, rather than thinking of children's mental ability or cognitive ability as small apples and adults' mental ability as large apples, Piaget said that comparing children to adults is like comparing apples to oranges. The way that a child thinks is qualitatively different than the way that an adult thinks. And over time, the quality of a child's thinking changes and grows. To Piaget, our mental ability forms through the use of schemas. Now, schemas are frameworks for organizing or for understanding information, interpreting information in the world. You might maybe think of schemas as kind of like file folders. And according to Piaget, we develop mental schemas for things that happen in the world. So one of the earliest schemas that a child would need to develop would be the schema for sucking, because that's important for nursing. But as the child grows and develops language, it develops schemas for various types of objects. So for example, the child would have a schema for car, or a schema for doggy, or a schema for horse. Now Piaget said that we begin with just a few schemas, kind of like beginning with a few file folders, and over time we have to take new information that we encounter in the world and either put it in those file folders, those schemas, or expand our file folders and have more file folders available. Assimilation is the process of incorporating new information into our existing file folders, or that is, incorporating new experiences into our existing knowledge, our existing schemas. So let's say, for example, that a child sees a car and points to it. A very young child points to it. And so here's this large object that moves, that has wheels, and makes a noise. The child looks and points, and the parent says, "Car! Car!" And the child develops a schema for car. Now, the car the child may have seen was a little blue Volkswagen Beetle, but maybe the next car the child sees is a long Lincoln Continental, black in color. But the child looks and points at that. It's a large object, it has wheels, it makes noise, and the child assimilates this new object into the same schema of car. So the child points and says, car. The parent says, that's right, that's a car. What would be another example of assimilation? Let's say that the child first learns to identify a dachshund as a dog. Maybe the family has a dachshund, and the child learns that that's a doggy. And so the schema for a doggy includes dachshund. But then the child goes to a relative's house, and they have a German Shepherd, a much larger dog. And the child looks at it. Well, it's furry, it has 4 legs and ears, and it barks. And the child says, doggy. Parent says, right, that's right. What's happened here is the child has assimilated this new type of dog into their schema of doggy. So now their schema for doggy includes both a dachshund and a German Shepherd. But sometimes we'll see children make errors. So let's say that the next animal the child sees is a horse. Well, it's large, it's furry, it has 4 legs, and the child points and says, doggy. What's the parent going to say? No, that's not a doggy, that's a horsey. The child looks intently at it and forms a new schema. Now we've got a new file folder, a new schema. We have a schema for doggy, but we also have a schema for horsey. This process is called accommodation. That's when we adjust our schemas to allow new information in. So we may have to develop new schemas for the world, or at least modify the schemas that we have drastically to understand the world. Let's take that same example of accommodation with a car. Let's say that a child looks at a large vehicle that has wheels and makes sound and moves, and this vehicle takes off from the airport because it's an airplane. But the child looks at it and says, it's a car, it's a fly car. The parent may laugh but then say, no, it's not a car, it's an airplane. The child now has to accommodate his or her schemas, adjust them, or form a new file folder, in a sense, for airplanes now. And maybe jet and helicopter and airplane can all go in the same schema, but a car or a truck certainly can't go in that same schema. So you get the idea how we assimilate some information, new information, into our schemas, and we accommodate and form new schemas for new information. This same activity, the same cognitive activity, occurs not just for very young children, but throughout life. And in fact, while you go to college, one of the processes that is occurring is that you're developing new schemas. You're either assimilating the information you're learning into the schemas that you already had, or you're developing by accommodating and coming up with new schemas for this new information. Next slide. Piaget said that cognitive development occurs in 4 distinct stages. The first stage of cognitive development he called the sensory motor stage, because we're learning through our senses. So think about this. What's the first thing that a baby does with any object that you give it? If the child is able to move the object at all, it's probably going to take that object and put it right in its mouth. Why? Why would babies put things in their mouth the first time they get them? Because it's part of sensing that object. They can touch it, they can hear it, for example, if it rattles, they can see it, but they also want to put it in their mouth and sense it in that fashion too. So Piaget noticed this, and he said that cognitive development or cognitive functioning occurs during this earliest period of life, occurs through our senses and through our movement. In fact, he said that at this age of life, the speed of thought is the speed of movement, or the speed of our senses. This stage, Piaget said, basically lasts from birth until about 2 years of age, though it'll vary some from person to person. And there are a few things that have to happen during this period. One of those things that has to happen during this period is the child has to develop object permanence. In a very young child, say earlier than 6 months or earlier than 8 months, We see that babies will orient towards interesting stimuli like a rattle or keys or something like that. But the moment that you take those stimuli out of its sight, the child immediately orients to something else, almost as if that object doesn't exist anymore if it's out of sight and out of mind. So in the pictures at the bottom, what we see is a child with a toy in front of it, and a cloth is placed in front of or over the toy, and the child reaches down and pulls the cloth off. In other words, this child has developed object permanence. She knows that that object still exists even when she can't see it, even when it's covered up. Before 6 to 8 months, the child would not have been able to do this, not have recognized that the object still exists even when it's not in sight. So a big developmental task during the sensory motor stage is developing object permanence. Take a look at these two videos that show before object permanence and after object permanence. Next slide. The second stage of cognitive development, according to Piaget, was called the pre-operational stage. Operation basically means being able to do mental operations in your head. During the pre-operational stage, children only have a limited ability to think. So they're developing thinking abilities that are beyond just their senses, but it's fairly limited. Piaget said this occurred from about 2 to 6 years of age, although it will again vary from person to person. There's really early evidence of thinking going on during this time, but you can see that some of the mistakes children make give an example of how their thinking is limited. So, for example, the child at this age, during this stage, is egocentric. This doesn't mean that the child is vain or prideful. What it means is that the child can only see from his or her perspective. So let's say that you have a box on a table, and the child is looking into the box. And you place an object into the box, a toy. Let's say you place a Mickey Mouse into the box, and the child is staring at the Mickey Mouse in the box. Then you go across the room and sit down, where it's clear that you can't see the Mickey Mouse. And you ask the child, "What do you see?" The child says, "Mickey Mouse." And then you say, "What do I see?" Can the child tell you what you see from your perspective? No, the child will say, "You see Mickey Mouse," even though you clearly can't see Mickey Mouse because you're across the room sitting down. Why would a child do this? The reason is the child is still not able cognitively to be able to take the perspective of another person. So during this time, during the time of the pre-operational stage, the child will gradually develop that ability to see from other people's perspectives. They may be able, at the end of pre-operational stage, to understand that other people have thoughts and other people have motives, and that other people can also be wrong in their beliefs. In addition, that other people have different physical points of view. A second task during the pre-operational stage is to develop what's been called conservation. Conservation of matter, conservation of number. Conservation basically means that the child is able to understand that however you rearrange objects, those objects are still the same. In the video link below, you'll see a child trying to learn developing conservation tasks. Typically, these tasks are going to involve something like pouring water from a short container to a tall container and asking the child which was more. Was there more water in the short container or the tall container? Before developing conservation, the child will not be able to understand that it's the same amount of fluid, whether it's a short container or a tall container. After developing conservation, the child will be able to understand it is the same exact amount of fluid. The same thing with a number of objects. So go ahead and watch this video because it's a good illustration of the development of conservation during the pre-operational stage. Next slide. Third stage of cognitive development Piaget called the concrete operational stage, and he said it lasted from about 7 to 11 years of age. At this point, children are able to do mental operations. That is, they're able to solve problems in their head or do thinking tasks in their head. An example would be math. So if you give the child a problem 1 plus 1, they can understand that it's 2. Or if you ask them, if I have 2 cartons of milk and you give me 2 more cartons of milk, how many cartons of milk will I have? And they'll say 4. So they're able to do these kinds of mental operations in their head, whereas before they could only do them physically with objects in the real world. Children are able to do those conservation tasks. They're also able to see from others' viewpoints. So the egocentricity has been lost, and now they've developed that ability to think in that concrete operational stage. However, children are not able to think very well symbolically in the concrete operational stage. So for example, they may have difficulty understanding parables or sayings. You may have heard this saying before. Maybe you had a grandmother or mother who said to you, "You can attract more flies with honey than vinegar." At a concrete operational stage, the child is most likely to see this as take this kind of a saying literally rather than to understand its symbolic meaning. So at the concrete operational stage, a child may say the meaning of this is that flies like the taste of honey and flies don't like the taste of vinegar. Well, that's correct, but it's a very literal interpretation. Most people are going to understand, once they get past the concrete operational stage, understand that this is actually a symbolic meaning and it refers to people. So after the concrete operational stage, a child is more likely to say, well, it means that you can attract more people by being nice to them than by being mean to them. Another phrase might be that we might use is "don't count your eggs before they hatch," an old-fashioned saying. And a child in the operational stage might say, well, it takes some time before eggs to hatch, so you probably shouldn't count them because it takes a long time. Again, a very literal interpretation. Someone who's past the concrete operational stage would understand that this refers more to your expectations about the future, and don't expect things to happen before they actually come to pass. Next slide. Piaget's fourth stage of cognitive development is the formal operational stage, and this is the last stage that we reach. So you as an adult will hopefully be in the formal operational stage, which occurs somewhere around 12 years of age and lasts on through adulthood. Children, or we should say adolescents and adults in this stage, are able to think abstractly, to be able to use symbols, for example with algebra. So if we gave someone in the formal operational stage the problem, if x equals 2, then 2 plus x equals, they'd be able to give us the response of 4. A child in concrete operational stage before would not be able to do this sort of abstract problem. Children in the formal operational stage are also better at using if-then reasoning. That is, if I do such and such, then something else is likely to happen. So they're able to understand better the consequences of their own actions and other actions. In the video below, children from various stages were asked the question, what would life be like if we had no thumbs? And it gives a good illustration of the difference between concrete operational reasoning and formal operational reasoning. So go ahead and look at that video before you go on to the next slide. Here's a graph, a nifty graph that shows the percentage of students in the various stages of Piaget's theory. And if you look at age and years, you see that at age 5, most children are in the pre-operational stage, and some are already in the concrete operational stage. If we look up to, say, age 10, we find that there are very few children, a very small percent, that are still in the pre-operational stage. Many in the concrete operational stage at the beginning, and a number of them have already reached the more mature phase or the more advanced part of concrete operational reasoning. And we see that some of them are already starting in with formal operational reasoning. Moving up to age 14, we find that there's very few in pre-operational. Not too many in concrete operational, the early concrete operational. Some in the more mature phases of concrete operational. And at age 14, we're seeing more formal operational reasoning. This gives you a picture that it isn't a matter of at age 7 we suddenly cease to think in one way and think in another way, but that we gradually shift from pre-operational thinking on up towards more concrete and then formal operational thinking. Next. This is the end of the lecture on the first part of development and the cognitive development of people. The next slide will be looking at the application of the cognitive development in social situations. That is, how does morality develop? End of lecture.